It absolutely deserves more emphasis. You're absolutely right. It's a great question to ask. So everyone, just to provide some context, Yash is asking about this case of the A implies B. So in this case, we're using the example A equals the logical sentence, cut the red wire, and B equals the logical sentence, the bomb explodes, right? So someone has made the statement, if you cut the red wire, then the bomb will explode. And Yash is asking, I feel like it's not quite in this third case where you don't cut the wire and the bomb still explodes. I feel like that's still somehow inconsistent with the idea of if you cut the red wire, then the bomb explodes. So I want to clarify this a little bit. So what the key thing here is, when the person makes the if-then statement, what they are doing is they're asserting something that's true about the world. And the reason that you produce this truth table and you don't use another logical convention is, the question on the table is, can I prove this person wrong? That's the way to look at it. That's the way Boole looked at it. That's why he adopted this convention. He cares a lot about scientific falsification. So that's what we're going for. So in the first case, you cut the red wire, the bomb goes off, that person is right. The world we're in is consistent with what that person said. In the second one, we just proved them wrong. They cut the red wire, but the bomb didn't explode. They are wrong. This sentence is false. We proved them wrong. In the third case, though, if you didn't cut the red wire and the bomb still exploded, and you went up to that person and you were like, you are a big liar. You said that you had to cut the red wire to make the bomb went off. The bomb went off. The person would say, hey, I made a statement about what happens when you cut the red wire. I didn't make a statement I didn't say bombs only go off. I would have said if and only if. I didn't say there's no other way to detonate this bomb. I said, if you cut the red wire, the bomb will be detonated. And you would have a hard time proving them wrong. And that is what this implication statement is. Now, it's absolutely the case that the real language doesn't necessarily line up perfectly with the logical language. This is the convention that was adopted by Boole. It's the convention that is used in Boolean logic. It's used in Python. We're going to use it in class because it forms all this computer science concepts. And the reason it was chosen is for this falsification reason, because you cannot prove in this case that cutting the red wire doesn't set the bomb off. And that's what the person said. They said, if you cut the red wire, the bomb will go off. And in this case, can you prove them wrong? No. So we are charitable in this case, and we assume that they are right because we've seen no evidence to the contrary. In the case where they cut the wire and the bomb didn't go off, we have seen evidence to the contrary. We know they are wrong. We're 100% certain it's false. But in this other case, no wires got cut. And so the hypothesis didn't really get tested. And that's why the convention is this way. Does that make sense? Cool. Thanks for indulging me. I'm going to put this in chat. Thanks, Josh, for sticking around and asking this question. It's really important.